Hello everyone. So today's lesson would be about kinematics. So what is kinematics? Kinematics is the study of motion. So let's begin. So before we go into motion, we need to understand the difference between scalar and vector quantities. Scalar quantities are those which have only magnitude. What does magnitude means? Magnitude means size. So these quantities include mass, speed, distance, volume, energy. Mass is the amount of matter inside of something. Speed is the amount of distance moved by an object per second. Distance is the amount of length moved by an object. Volume is the amount of space occupied by an object. Energy is the ability to do work possessed by an object. Vector quantities are those which have both magnitude and direction. These include force. Force is a push or a pull. Acceleration is the amount of change of velocity per second. Velocity is the amount of distance moved by an object per second in a particular direction. Momentum is the difficulty of stopping an object, how difficult it is to stop an object, the measurement of that. Moment is the turning effect of a force. All of these quantities have both magnitude, meaning size, as well as a direction. We'll get on to these in the next chapters. So the next thing, the key terms include distance. Distance is the amount of space covered by an object, just like I said, the length moved by an object is expressed in meters. Displacement is very similar to distance. However, distance was a scalar quantity while displacement is a vector quantity, because displacement is the distance moved in a specific direction. So it has the same definition of distance, but along with that it has a direction as well. Because it is a type of a distance moved, that is why the meters are still the SI unit for displacement. Speed is the rate of change of distance. How much distance you move per second, that is what speed is all about. So speed is expressed in meters per second. How many meters you move per second. Velocity, like I said, is a vector quantity which is very similar to speed. It is the rate of change of displacement. So what did we learn? Displacement and the difference between displacement and distance was the distance was the amount of space moved by an object without specifying the direction. But displacement is the distance moved by an object in a specific direction. So that is why velocity, because it is the change of displacement, what does it mean? That means it is a vector quantity as well, because it refers to how much distance an object moves in a specific direction per second. Okay, because it is a type of speed, but the speed in a particular direction, that is why it has the same unit as speed. The last thing is acceleration. It is the rate of change of velocity. So acceleration, as we learned in the previous slide, that it is the vector quantity as well, just like velocity. So acceleration is the rate of change of velocity. That means how much the velocity of an object is changing per second. So as we learned, velocity is the speed in a particular direction. So because velocity is a vector and speed, and since acceleration is the rate of change of velocity, it automatically has its own direction, because velocity has its own direction as well. And because it is the rate of change of velocity, what does it mean? It means the amount of meters per second that changes per second. The amount of meters per second, meaning the amount of velocity that changes per second. So that is why its unit results in meters per second square. That is what we got here. The next slide. Example. So distance, Andy moved 5 meters. This one is basically defining the distance that Andy moved. He moved 5 meters and there is no specification of any direction. That means it's a scalar quantity. Displacement of this, Andy moved 5 meters to the right. So this over here, it's not only mentioning the size of the distance moved by Andy, it is also mentioning the direction. That is why it is a displacement. It has a direction. Speed, a car is traveling at 20 meters per second. That means it's traveling 20 meters every second. As you can see, there is no mention of any direction. However, in the second one, velocity, a car is traveling in the north direction at 20 meters per second. So the direction is mentioned as north, and the speed, the size of the speed is also mentioned. So the size, meaning the magnitude, is mentioned as well as the direction. So this is velocity, which is speed in a particular direction. This was displacement, which was distance moved in a particular direction. So these are basically the comparisons between scalar quantities and vector quantities. The directions could be north, south, east, west, forward, backward, left, right, etc. You know the things. So this basically explains to us what the proper difference between distance and displacement is. So in here, as you can see, if we start from A, if a person starts moving from A, that person moves 3 meters to the north, then 5 meters eastwards, 3 meters southwards, then 5 meters westwards back to A. So in such cases, the distance moved is how much? 3 plus 5, 3 plus 5 plus another 3 plus another 5. So if we add all of these, 3 plus 3 is 6, 6 plus 10 is 16 meters. This is the distance moved by the object if it starts moving from A. However, the displacement is the distance moved in a particular direction. So if it's the distance moved in a particular direction, that means it has to have some way of, telling us that it has a specific direction. So if, let's say, we take the forward direction as positive, if we take the forward direction as positive and we take the backward direction as negative, so this is the forward direction and this is the backward direction. Okay, forward direction meaning the object is moving forward, and this is the backward direction meaning the object is moving backwards. So if we take the forward direction as positive, that means what? Plus 3, then here plus 5. These are the positive values because the object is moving in the positive direction. So plus 3 plus 5 plus this one is in the negative direction. The object is now moving in the backward direction, so it should be plus minus 3. Please notice carefully that we are adding all of them. Displacement is simply the addition of all of them, but even though we are adding, because they have different directions, they have a negative in front of them. And what's the last one? It's also moving towards the backward direction, 5 meters. So plus minus 5. So if you add all of these, plus 3 plus 5 gives us plus 8. Then minus 3 minus 5 gives us minus 8. So plus 8 minus 8 gives us 0 meters. So even though the distance that I moved was 16 meters, the displacement is 0 meters. You know why? Because the object has actually come back to its original position. It has come back to A. So if the object comes back to its original position A, regardless of how much distance it has moved, its displacement is still 0. That is why in, let's say, a case where a person has moved from a country to another country and back, let's say he moved from country A to B and then B to A. So let's say he has moved from A to B. Let's say he moved 1000 kilometers and then 1000 kilometers back, right? So the total distance moved by the person was 2000 kilometers. This was the distance, right? Distance. But if we consider the displacement, it was plus 1000, meaning A to B was the positive direction and B to A is the negative direction. So it's plus 1000 going from A to B, and it's minus 1000 from B to A. So if you add these, you get 0. So even though your distance moved by the object is 2000 kilometers, so not the object, but the person is 2000 kilometers, but the displacement of the person is 0 kilometers. Why? Because the person has eventually come back to their original country of origin. The next one, speed, how fast an object is moving. So speed is the amount of distance an object moves per second. So that's why the speed is expressed in meters per second, how many meters you move per second. Okay, so if you write the formula, speed is distance divided by time, and in symbols, speed is represented by v, distance is represented by d, and time is represented by t. So d divided by t will give you v, which is the value of the speed. So average speed is the total distance by total time taken. So average speed and instantaneous speed, we need to have a discussion about that. So average speed is the total amount of distance you move throughout the distance in the total time taken. So let's say throughout the distance you have moved through 2000 meters and it took you, let's say, 200 seconds to do so. So your average speed is 10 meters per second. How? You cut them off, right? 2 and 10, 2 and 20 gives us 10. So 10 meters per second is the average speed of the object. So why does it say average speed? Because throughout all of the 200 seconds, the object's speed may not have been the same at every second. Let's say at the first second its speed was something, second its speed was something else, third second its speed was something else. So the speed throughout the throughout every second could be changing, but overall, the overall speed, considering the entire journey, considering the entire time taken and the entire distance moved, that speed is called the average speed, which takes into consideration the entire journey and not just any point or any second or third second, 10th second, 20th second. No, we don't consider any specific time slot. We consider the entire journey, and that is why it's called the average speed. So word problems. So let's say I'll solve a few of them. Let's say I want to find the speed of the car which is traveling a distance of 200 meters in 10 seconds. So the formula was distance by time taken. So distance is 200 and time is 10. So 200 meters by 10 seconds, it comes to 20 meters per second. This was number 1. Now if I consider number 2, this is a bit tricky. If you look at it carefully, it's moving 3 kilometers in 20 minutes, and our objective is to make sure that the speed is expressed in meters per second. So distance is how much? 3 kilometers. Now 3 kilometers, we learned in the first class physics basics that if we wish to convert kilometers to meters, we multiply this by 1000. This is going to convert the kilometers to meters. And if I wish to convert the minutes to seconds, so 20, and every minute there are 60 seconds, so 20 into 60, this will convert the minutes to seconds. So whatever the answer comes to, that should be giving you the velocity of the object. So that's it. So yeah, so I wanted to show you how to actually differentiate between something which is simple, where the speed is simply in meters per second, and in cases where the distance moved is mentioned in kilometers and the time is mentioned in minutes. That means we had to convert both of them into meters and seconds respectively. Okay. Now there are two sorts of experiments to calculate speed. One is using light gates, one using stopwatch and measuring tape. So the one using light gates will give you instantaneous speed. Instantaneous speed. And the one using stopwatch and measuring tape will give you the average speed. So we just got to learn about average speed in the in a few slides ago. So instantaneous speed, what does it mean? Instant. What does it mean? Instant means a moment. Instant means a moment. So the specific moment of the journey, whatever your speed is, that's called the instantaneous speed. So if I wish to know what was the speed of the object at the 10th second of the journey, that is called the instantaneous speed. So at a specific instant of the journey, if you wish to find the speed of an object, that's called the instantaneous speed at that specific instant. Okay. So light gates will be used to find instantaneous speed, while stopwatch and measuring tapes would be used to find average speed. So let's first deal with the finding the average speed of the toy car. So to calculate the speed, we need to know distance it traveled and the time for the journey. So toy car is given a force which causes it to move a certain distance in a certain amount of time. So let's say I draw a toy car over here. Okay, this is the toy car, and I'm giving it a small starting force. A small, don't give it too large a force, just a small starting force from here. Okay, this will cause it to move forward. So it starts moving from here. So the moment it starts moving, you start the stopwatch. Okay, you start the stopwatch the moment it starts to move. Okay, so we need to have two people, one person to actually give the push and the other person to start the stopwatch. Okay, and then once you have, let's say, taken a specific amount of distance moved by the object, let's say you don't want to keep it moving for too long. Let's say you want to keep it moving from let's say here up to here. Okay, so let's see, you made it move, let's say maybe 100 meters max, no more than that. Okay, you made it move 100 meters in the lab. 100 meters is a pretty long distance, right? So you made it move 100 meters in the lab. Pretty long track. So this 100 meters, if you make it move 100 meters, your other friend has to measure the time taken to move this 100 meters. So he starts the stopwatch when the object starts to move, and he stops the stopwatch once the object has reached the 100-meter marker. It has to reach the 100-meter marker. Once it has done so, the person stops the stopwatch. So you already measured the distance 100 meters from before setting up your track. You measured the distance 100 meters using how did you measure this? You used a measuring tape to measure this, and the stopwatch was used to measure the time taken to complete the 100 meters, right? So what else do we do to find the speed? As usual, we use the formula total distance by total time. This will give us the average speed of the toy car. Okay, so we measure the total distance, which is 100 meters, and we measure the total time from the stopwatch, the starting time up to the stopping time. That will give us the speed, average speed of the object, right? So it starts at time 0, It starts at time 0. Let's say it takes 10 seconds. So if we wish to, let's say, do a math of it, so the speed would be distance moved is 100 meters and time taken is 10 seconds. So 10 meters per second is the average speed of the toy car. Now there are some few possible sources of error. While measuring the distance, the error could come from the parallax error while measuring the distance from the measuring tip. And in the first lesson of physics basics, we learned that parallax error happens whenever we look at an object from an angle. Let's say this is 10.2, this is 10.1, this is 10.3. So let's say the actual correct distance is 10.2, but since I'm looking at this 10.2 from the side, I'm seeing 10.3. I'm overestimating it. Or if I'm seeing 10.2 from this side, I actually see 10.1, even though my actual distance is 10.2, but since I'm looking at it from sideways, from either left or from right, I either underestimated or I overestimated. So to get the perfect distance, I have to look at it directly, vertically, perpendicularly towards it, not from sideways, directly towards it. That will avoid the parallax error. And the error which could happen while measuring the time is called the human reaction error. And the human reaction error could be, of course, it's going to be there. Human beings are not perfect. We do take some time to react. So that reaction time could be, made as less as possible through more and more experiments being done. You should do this experiment more and more times so that the human reaction times slowly becomes, very close to zero. It's not going to become zero, but it's going to become very close to zero through repetition of the experiments, through more and more practice. Then we go on to how to measure the speed using the light gauge. This one will be how you find the instantaneous speed. Instantaneous speed. Okay. So the instantaneous speed is the speed of an object at a specific instant, right? So we need to make use of the light gauge when the object's front. Let's say this is the light gauge. This thing is giving off a beam of light, and this light gate has been connected to something called a data logger. Data logger. What does a data logger do? A data logger, just like a call log, records the phone records the incoming calls, the outgoing calls, the missed calls. The data logger records data which has been collected by the light gate. So let's say the object, a toy car, is approaching the light gate. It's coming this way. Let's say this has a length of 1 meter, let's say. So when the moment the front of this light gate touches the light of the light gate, let's say I redraw it, the front of the object, the toy car, has now just touched the light of the light gate. So when this happens, this is when the interruption starts. This is where the interruption of the light starts. Before this thing actually touched the light of the light gate, was there an interruption? No, there was no interruption because the light was flowing smoothly. But the moment the front of the object touches the light of the light gate, the interruption of the light starts. So whenever the interruption of the light starts, that is when the data logger starts a stopwatch inside of it. A stopwatch starts inside of a data logger, and the timer has started inside of the stopwatch. So when does this stopwatch stop? So this stopwatch stops when the back of the object, has just left the light gate. So when the front of the object touches the light of the light gate, the interruption starts, and when the back of the object has just left the light gate, the interruption has stopped, right? Because once the object has left, there is no more interruption, right? The interruption is gone. So when does the interruption exactly stop? When the back of the object just leaves the light gate. This back of the object, when it just leaves the light gate, that is when the interruption stops. Just like the moment when the front of the object just touched the light gate, that is when the interruption started. Similarly, the moment when the back of the object just leaves the light gate, that is where the interruption stops. So this time of interruption, okay, the time taken between the front of the object to touch and the back of the object to leave, this time of interruption is measured by a stopwatch inside of the data logger. So this is taking the time of the interruption. How much time was spent by the object interrupting the light of the light? So how much was the time? It was the time taken for the object to completely pass through the light gate. Completely pass through the light gate. So this was the time taken by the object. Okay. And how much distance did the object move while completely passing through the light gate? Its length, its front until its back. How much time was the interruption for? For as long as the front of the object touched the light gate's light, and until the back of the object left the light gate's light. So this is the amount of distance it had to go through to stop the interruption, for the interruption to completely stop. So the distance moved is actually the length of the object itself. So if we just try to do a math of an example just to understand how it actually happens. So let's remove everything from here. Okay, so now let's just do a math of it and we can understand exactly how this thing works. So let's say I said that the length of the object was 1 meter. So because the length is basically the distance it moves, so distance is also 1 meter, right? And the time of interruption, meaning the time for the back of the light gate to completely leave the light gate, sorry, back of the object to completely leave the light gate. So the interruption time was how much? The time between the front of the object touching the light gate, that was when the interruption started, and until the back of the object left the light gate. Okay, so let's say we take this time to be, let's say for example, 0.05 seconds. So the velocity, the instantaneous velocity, this is giving me what? The instantaneous velocity or the instantaneous speed, the exact speed at this point, at this part of the journey, whatever the velocity of the object is, that is the instantaneous velocity of the object in here, right? So this light gate is going to give me the instant velocity at this specific point of the journey. This journey is huge, right? It started from somewhere here, it's going to keep on going, so the journey is big, but I'm just bothered about the exact value of the velocity at this specific point, right? That is why I call it the instantaneous speed, at this instant moment, right? So the distance is how much? Again, use the same formula, d by t. So here the distance is 1 meter. So why is the distance 1 meter? Like I said, the distance moved is actually the length of the object itself, the amount of length it had to move for the interruption to stop. So what was that length? From the front of the object to the back of the object. That distance is actually the length of the object, which is 1 meters. So 1 meter divided by time is 0.05. So it comes to, I guess, 20 meters per second. Yeah, it comes to 20 meters per second. Yeah. So that's how you find the instantaneous speed of the object at a specific point using light gates. So this is what a light gate actually, this is how it looks like. As you can see, it's connected to a laptop, and the laptop is basically containing the data logger where the stopwatch is, timing it. So the next thing that we do is acceleration. It's how much the velocity is changing per second. Just let's remove it, make it a bit better. Per second. So the amount of velocity that is changing per second, that's called acceleration. So how much your velocity is increasing per second, that's called the velocity. So that's called the acceleration, sorry. So the acceleration is change in velocity by time taken. So change in velocity means what? Final velocity minus starting velocity. So final velocity minus starting velocity, that is the what? Change in velocity. How much the velocity has changed. How much it was at the beginning, how much it is at the end. That is the difference between them is the change divided by the time taken. So that is the change in velocity by time taken, which gives me the acceleration. And we just discussed how we got the unit of acceleration to be meters per second square a few slides back. So you can take a look at it if you want to. So word problems, I've given a few of them. Motion graphs is for the next topic. Today we just deal with the word problems related to acceleration. So let's say we deal with this one, number 8. Okay, an object is accelerated from rest. So the starting speed is 0. At rest means 0. Then the final velocity is 10, and it takes 2.5 seconds for the object to go from 0 to 10 meters per second. So what's the acceleration? V minus u by t. final velocity minus starting velocity by time taken. So 10 minus 0 divided by 2.5, which comes to 4 meters per second squared. That is the acceleration of the object in question number 8. Okay, so now that we're done with this one, number 9 we're not going to do now, because number 9 involves another equation, v square is equal to u square plus twice as. This is something we are going to learn in the next class. So once we have done that, then we will come back to this one. So let's move on to this one. Let's say we move on to number 3. So in here they're saying that the car picks up speed as it rolls down the slope. As it starts down the slope, its speed is 4 meters per second. It accelerates at a rate of this. What is its velocity after 3 seconds? So if we make use of this formula again, here they have already given us the acceleration, which is 6 meters per second squared. So we write this 6 meters per second squared, and they are asking us what is its velocity after 3 seconds. So we have to find the final velocity after 3 seconds, and the starting velocity was, as it starts down the slope, its speed is 4 meters per second. So its starting speed was 4 meters per second, and the time is 3, right? That is the time after which we have to find the final velocity for, right? So over here, v minus 4, it comes to how much? Cross multiply 3 and 6. So we get how much? V minus 4 is equal to 3 into 6, 18. And v is equal to 18 plus 4. So v would be equal to 22 meters per second. So this object, which was initially at a speed of 4 meters per second, after 3 seconds, its speed would become 22 meters per second upon accelerating at 6 meters per second square. Okay, so this is how you find acceleration from these things. So yeah, that is our lesson for today's class.